Hello, my name is Owen, and welcome to my YouTube channel.
So today we're going to make some brackets for a sliding GoPro mount for my workbench. It's some simple machining out of some aluminum angle, so I'll start by cutting them to length. But obviously our cold saw is not working. It's chooched and has seen better days, so we're going to go over to the bandsaw and start cutting those to length. So right here we're lining up the blade with the scribe marks that I've made on the aluminum. Tighten the vise with the start button and let it cut. We've got a pretty coarse blade in it and I don't want to change it out for the cuts that I'm making, so I'm just feeding it slowly by hand. And then we'll walk back over to the mill. Here we're just scribing some general layout lines so that we know where our holes are supposed to go roughly. I generally do this just so if I do something dumb on the digital readout on the mill, I can catch it because I can see that it's not where it's supposed to be. Our holes are spaced 20 millimeters apart, so I'm setting it to 10 millimeters, scribing a line, and then setting it to 30 so that the dimensions are all referenced off of one edge. They're supposed to be 40 millimeters long, but I don't trust my eyeballing on the saw cuts to be plus or minus half a millimeter. So we're doing it off of one end so we don't introduce any error there. When I'm drilling into angle, I generally pinch it with a 1-2-3 block in case I have a parallel, a 1/8 inch parallel underneath it, because this is 1/8 inch wall angle. So the 1-2-3 block makes sure you're pinching the angle, and then it's resting on a parallel up at the top to keep it level. Throw in the drill chuck, and we'll be ready to go. So we're going to grab a number 7 drill, which is roughly a clearance for 5 millimeters. Okay, we'll grab a number 6. But before we're going to spot it using a 3/8 spot drill so that it doesn't wander since we aren't using a split point drill. We're just going to line up the first hole location by eye since we don't really care where it is. We care that the second one is exactly 20 millimeters away. Tighten the gibs down so it doesn't move on the Y, and then we'll tighten the X down right here. Now that we've got our first hole located, we'll come over to the digital readout, put it into 0, 1, and 0 that out. So that's our first hole location, and then we'll put it into millimeters. Now we'll swap out for our number 6 drill bit, which is our clearance for our 5 millimeter screws that we're using. And then we'll come and jog 20 millimeters in the x-axis for our second hole location. Note the holes don't line up to the scribe marks because I used the wrong scribe marks. Next we'll grab a 3/16 2-flute end mill for cutting the slot for the adjustment so that we can level this whole thing out once we screw it onto the workbench. Put it in a collet, put it in a taper, and here's the edges of the slot that we're milling to. I typically like to ramp in, especially on small end mills. If you plunge, you might end up just snapping it off. Here's both of the finished brackets. Next we just have to do some deburring and cleanup work, but that's nothing a right angle die grinder can't fix. Next we're going to tap the holes into the end of the aluminum extrusion. Note that these are 5mm by 0.8mm pitch using a Big Gator Tools tap guide. These things are super handy when you're not able to put it into a tapping machine or use a tap follower in a mill. They also have a V-groove along the bottom, so if you're tapping into a piece of pipe, it keeps the tap perpendicular to the pipe. I would definitely recommend spending the money on these. They're hardened tool steel and they work amazing. Shake all the crap out and then do the exact same thing to the other end. I cleaned the brackets off with some acetone and we're going to make sure it sits flat, but there's some burrs under there that I had to go buff off on the aluminum deburring wheel. Now we're going to install it on my workbench, so cue the montage. It moves pretty freely. The beam is actually straight, so it's not inducing any extra friction into the system. I think this project turned out great. I'm really excited to see what kind of shots I can get in the future with this thing. Thanks for watching. Make sure to stay tuned and subscribe to see what kind of cool stuff I use this for.